So the whole point of trying to find the pattern is to create the expression that goes along with it. You guys might see it as an expression would be y equals x plus 2. Okay, that's an expression. So this is the type of expression that you are trying to think of. So you know in a table of values that whatever you make x equal, so if I said x equals 2, it's going to determine the value of y, right? So in this equation, if I make x equal 2, what is y going to equal? 4. Okay, y would equal 4. Everyone see that? Okay, so we're used to working this way and having a table of values laid out and picking our value for x and then of course finding out what y would equal. So we need to do the opposite. In this case, you're going to be given a table of value and you have to decide, what am I doing? Like, what is x? What am I doing to x? I'm adding 2 to it so that it becomes y. All right? Always thinking about the 4 different operations. What are the 4 main operations in math? What do we usually do with numbers in math? You've been doing it since you were little. Exactly. Adding, subtracting, multiplying, dividing. Okay, your main operations with numbers. It can become more complex and you can have square numbers and you can have the root of the number, etc. We're just sticking with the basics. Okay, we're just looking at those 4 operations. So going back to this table, what we are trying to determine is if I have y, of course it's going to do that to me. I didn't press the... All right. If I have y and it equals, I'm doing something with the x to make it equal the y. So in my head, I already know what y equals in this case, right? So let's just look at the top pair, the top coordinates, -2 and -4. So we have to think, what could I do to make a -2 turn into a -4? So what can I do to the x to make it look like the y? Because what I'm saying is that y is -4 and x is -2. So what do I need to do to a -2 to make it equal a -4? I'll let you think for a sec. Navjot's got an idea here. So how would I make a -2 turn into a -4? And think about, can I add something to it? I would have to add a -2. Okay, so that is a possibility. Maybe I add -2 because if I insert -4 equals -2 plus -2, it does equal -4. So that could work. So then I can take that same idea, right, and I'll look at the next pair because it has to work for every pair. So let's try it for the next pair. If I have -1 equals -2 plus -2. Oh, if it's -2 plus a -2 again, it's not going to be a -1, is it? Okay, so we determined something that doesn't work. Okay, and we are going to do that in the process of trying to figure out what the pattern is, right? So that didn't work. Any other ideas of something that we could do to this x, -2, to make it a -4? All right, Navjot, what were you thinking? Add 6. So let's try it. So if I make it y equals x, -6, you say?
No, 6.
+6. Okay, so I'm going to erase Abdallah's possibility because it didn't work, right? So back to square one. Let's try something else. So if it's -4 equals x in the first pair is -2 plus 6. So -2 plus 6, does that equal -4? Nope. So is that one working? Nope. So back to the drawing board. So is there anything else you think might work? Nick, what are you thinking? -6 plus 2, like that? Is that what you mean? Okay, let's try it. So y equals, so let's insert x being -2 for that first pair. Okay, oh, and of course we already know the answer for y. -4, -6 plus 2. So -2, -6, that's -8, plus 2 is -6. So nope, that wouldn't be equal. So if I actually worked it out, it would be not the same on both sides. Nice try. I like it. You're adding like 2 levels of it. Okay, so that one doesn't work. Any other ideas? Okay, so let's go back to looking at these pairings. Okay, so we have -2 to a -4, -1 to a -2, 0 to a 0. The other day, Harry Ward looked at the 0. He said that that was his benchmark that he liked to use. So let's look at just those zeros. So what can I do to 0 to make it a 0? So let's think about the operations we've been using so far. We've tried to add and we've tried subtracting, right? So adding and subtracting. If we add anything to 0, is it going to become 0? If we subtract anything to 0, is it going to become 0? So that's probably not a good benchmark to start with. We know we have to do something else to the number. Of course you can, yeah. So do you want to try multiply? Yeah, so 0 by any number is going to get us 0. So we use that benchmark to help us figure out the possible operation that we're going to go forward with. So let's go back to another pair again. Let's go back to positive numbers. I like to focus in on positive numbers. It's easy to work with, right? 1 times what would get me to 2? So do you want to try multiplying x by 2? Okay, so let's try y equals 2x, because remember when we write it like that, it's multiplication, right? Okay, Avi, you still with me? Okay, so let's try if y is equal to 2. So I'm looking at this one right here, okay, guys? If y is equal to 2, it would equal 2 times 1. So 2 is equal to 2 times 1 is 2. Okay, so does that work? It works for that one. So now what do we need to do? To make sure something works really well, we need to try it with one of the other pairs. Okay, so let's try the next pair. Oh, I suppose I didn't have to erase that. 2x. Okay, so let's try it with this pair now. All right, so I'm just going to fill in the information. So y, right here, right, y is equal to 4. So I'm going to put 4 equals 2. And what's x equal in this pair, 2 and 4? 2. Okay, so 4 equals, what's 2 times 2? 4. So does that one work? Okay, so that works. That's good. So where should we double check to make sure it works other places? Should we try one of the negative numbers? Yeah. Okay, let's try one of the negative numbers. Okay, so let's focus in on, let's do this one again. So see this one, -1 and -2? Let's try those values. So if I look at my y value is, so where do I put that? Yeah, is equal to 2. And what's the x equal in this case? Times -1, or times, you can put a times, like a multiplication sign here too. I just put brackets. It's the same thing though. And what's 2 times -1? When you multiply a negative and a positive, it's a negative, and 2 times 1 is? -2. So does this work? Yeah. So we found the expression for this table of values. Okay? It is a lot of trial and error. The only way you get better at it is by practicing and trying it. Okay? There's no magical answer. I liked that Harry Ward pointed out the other day that he looks at the zero pair, and I honestly had never thought of that before as a teacher. I've just, trial and errored it, positive numbers, negative numbers. I never thought of that benchmark. So just that idea of using that zero to kind of see what's going on is probably a good place to start. Okay? We are going to try a few more. You ready? Okay. Let's try a few more. Okay, I'm going to give you another table of values, another x, y. Oof, that's an ugly line. Come on. X, y. All right, I'm not going to make it up in my head real quick. I'm not going to make it hard. So what you're trying to do, the goal that you're trying to accomplish is finding the pattern. So Adam, I think you're in the bathroom for this part. We have always been, so far, I've given you like y equals 2x. Okay, and then what I do is I say, here are your x values. Don't write this down, guys. And then you have to put x in and figure out what y equals, right? So we're actually now doing the opposite, Adam, where I'm not giving you this. I'm actually giving you the table of values and what the value is, and you have to come up with what is the expression that represents the table. So it's just the opposite, yeah? Okay. Oh yeah, it's new. It's something you've never done before, so it's a little odd, right? Okay. 2 times. So what is happening? What am I doing to x to make it equal to y? And of course, I'm using at least one of the 4 operations. I'm either multiplying the number, dividing the number, adding something to the number, or taking something away from the number every time. Right, Grayson? Right. You're looking at the pattern? See if you can figure out the pattern. You should be writing this down in your notebooks as examples for a test. Is Navjot the only one who sees a pattern so far? All right, what do you think I'm doing to those numbers then, Grayson? So it just becomes 3x. And you are correct, because we have 1 minute left. I'm not going to prolong it. If I now insert, so let's try this first pair. Y is equal to negative 6 equals 3 times x in this case is negative 2. Does it work? Are they balanced on both sides? Negative times a positive. 2 times 3 is 6. Negative 6, negative 6. Yep. Let's try the next one. 3x. Let's try a positive pair, just to double check. So y is equal to the 6. So 6 equals 3 times x is equal to a 2. 6 equals 3 times 2. 6 equals to 6. Are they equal? Yeah. So it works. Okay, you have determined the pattern. What you're doing every time is multiplying by, in this case, 3 to get to the y. Times 3 equals, times 3 equals, 0 times 3 is, of course, 0, so that works. 1 times 3 is 3, and negative 1 times 3 is negative 3. So they all check out. Okay? So when you're answering this and it says write the expression for this table of values, this is your answer. Y equals 3x. And we will do more difficult ones tomorrow.